If your Elasticsearch search feels either exact or semantic, you're leaving relevance on the table. We'll wire BM25 and kNN together with Rescore so the first page finally looks right. Maybe your search returns exact matches that ignore related meaning, or it gives semantic matches that miss the precise term the user expects. By the end of this video, you'll understand how to get the best of both worlds. You will see how to build a small hybrid pipeline in Elasticsearch that uses BM25 for exact relevance and kNN vectors for semantic recall. I'm Professor Pi, teaching search and IR from basics to advanced with simple, concepts-first Python that helps you solve bigger real-world problems. Hybrid search with Rescore addresses a common pain. Users type short queries. They often expect exact terms when present, yet still want related concepts surfaced. Pure lexical search like BM25 is great for exact term importance. Pure semantic search with vectors finds related items, but can ignore exact keywords. Combining them gives better first-page relevance with modest engineering cost. The intuition is simple. Use vectors to find a pool of semantically relevant candidates. Then use BM25 to reorder that pool so exact hits rise to the top. Think of it as broad recall from vectors and focused precision from BM25. For example, a user types headphones. A vector search might return wireless buds and an audio amplifier as similar items, while BM25 prefers documents that literally say headphones. Rescore blends that judgment inside a limited candidate window. We'll build a tiny demo index, add 2 documents, run a BM25 baseline, run a kNN vector query, and finally run a hybrid kNN plus Rescore search. The code is compact and uses a 2-dimensional embedding toy, so the mechanics are clear before you scale to bigger vectors or ANN indexes. Now we create the index mapping and client. This snippet creates an Elasticsearch index ready for BM25 and kNN search. It builds a client with Elasticsearch and defines a mapping M containing a text field text for BM25 and a dense vector field vec with dims equals 2 and index enabled for approximate nearest neighbor. The call indices create provisions the hybrid index named hybrid. We then verify the index exists using indices.exists and print a quick status. Increasing dims would store richer embeddings but consume more memory and typically increase search latency. Keep it minimal for quick demos. Seeing index created equal true confirms the index is ready for documents. Next, we add an initial document so searches have something to score. This snippet adds the first document so Elasticsearch can score something. We reuse the index name in IDX and call index with ID1, providing a short text, wired headphones, and a 2D vector that matches the mapping. The indices.refresh makes the right visible for immediate querying, which is handy for demos. The text field will be ranked by BM25, while the vec field will be used by kNN later. Frequent refreshes reduce indexing throughput, so in production you'd batch and refresh less often. The printed docs equals 1 confirms one searchable document is available. Now we show the BM25 lexical baseline and how it prefers exact terms. This snippet runs a BM25 lexical baseline using Elasticsearch's Search API. It first indexes a second document with wireless buds to introduce a synonymy case. Then refreshes the index to make it searchable. The query string Q equals text headphones performs a BM25 match on the text field and returns the top hit. We extract the first hit's undergop ID into top so you can see which document BM25 prefers. With a pure keyword query, the exact term headphones tends to favor the wired headphones doc over wireless buds. The BM25 top result shows how the lexical baseline behaves before adding vectors. Next, we run KNN over the same two documents to see semantic preference. This snippet issues a KNN vector search in Elasticsearch to capture meaning. We create QV near the second document's embedding and build KNNQ specifying the vec field, the query vector, and the candidate controls. The search call with KNN equals KNNQ retrieves the nearest neighbor by vector distance, independent of exact text matches. We pull the top hits ID into top to show which doc the embedding favors. Raising K or num candidates increases recall and stability at the cost of latency. Small values are faster but can miss close items. The KNN top result highlights the semantic preference for wireless buds. Now the key piece. Combine them with a rescore that favors exact matches. This snippet combines KNN recall with an Elasticsearch rescore that boosts BM25 exact matches. We define RS to rescore the top KNN candidates using a match on headphones, weighting the rescore query higher so exact term matches can overtake near misses. The search call passes both KNN equals KNNQ and rescore equals RS. So KNN gathers candidates and the rescore reorders them within window size. We then read the top hits ID into top to see the hybrid winner. Increasing rescore query weight emphasizes exact matches. Lowering it leans towards semantic similarity. The hybrid top result shows exact match preservation while still leveraging vector recall. Mapping this toy to a real project is straightforward. Replace the two-dimensional vectors with real 128 or 768 dimension embeddings from a sentence encoder. Use an ANN engine for TNN if you have tens of thousands of documents. Keep the rescore window modest, for example 50, to limit cost while letting BM25 correct top candidates. The same pattern scales from FAQ search to product search to legal retrieval. Recap. Hybrid search uses KNN to recall related documents and BM25 rescore to preserve exact match precision. Use this when users expect both semantic relevance and literal term importance, like product search or focused Q&A. One caveat is cost. Rescore operates only on candidates, but the candidate window and vector index tuning change latency and memory. Next practical step, tune the rescore weight and candidate count while measuring top K accuracy and latency on your dataset. Small changes to rescore weight often move the needle more than model swaps. If short, practical IR helps, subscribe and watch the IR videos.